Hi, I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. This time we'll look into vignetting with corner IDs instead of texture coordinates as we did in the last video. As always, a short disclaimer, this tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths. So if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you. Corner ID. I didn't understand that for quite a while and needed a lot of help on forums to start working with it, because the documentation as of today is horrible. With this function you can set a global state for all shaders being used where when enabled the shader steals 2 bits from the input color values. The first is from the lower bit of the red color value and the second is from the lower bit of the blue color value. These values can then be recovered in the shader to work out which vertex you're dealing with. In example, which corner. Okay, so I get it steals 2 bits from the color values. Probably the vertex color. But then what? What does that mean? How can I use that inside the shader? But with the help I got on the forums I can try to explain, although I'm still not able to fully understand everything here. Think of the vignette shader we created in the last video. We learned that to get a vignette on an image we need to get the center of the image first. That would be easy with a surface or a sprite on its own texture page. The center will always be 0.5, 0.5, because then the UVs go from 0, 0 to 1, 1. It would also be quite easy using GLFrag chord, because the center would always be the center of the view in pixels. The tricky part was applying the vignette to a sprite on a mixed texture page. We had to calculate the center of the sprite on the mixed texture page by getting the UVs of the sprite, pass them to the shader, and then normalize the distance of each fragment to the center. If we could only tell the shader which of the sprite's vertices is the first, second, third, and fourth, we could create our own normalized coordinate system ranging from 0, 0 to 1, 1, something like this. If vertex number is 0 or 3, x is 0. Else x is 1. If vertex number is 0 or 1, y is 0, else y is 1. But unfortunately the vertex shader has no clue about what vertex it's currently working on. But that's something corner IDs can help with. With the function shader enable corner ID, we can tell GMS to use the least significant bits of the vertex colors red and blue channel to store information on the vertex number. And since now the information is stored in the vertex color, a vertex attribute, we can retrieve that information inside the vertex shader. And since that information comes from a vertex attribute, the GPU can pass interpolated values to the fragment shader as we had learned in the last few videos. Let's say we can retrieve the information 0 from vertex 0 and 1 from vertex 1. Then the fragment halfway between vertex 0 and vertex 1 will get the value 0.5. And thus we have a coordinate system going from 0, 0 to 1, 1. So with the function shader enable corner ID, we can get that information into the vertex color. But how can we read that information on the vertex number from inside the vertex shader? Before explaining that, I will set up the project for testing. Let's just copy the object we created in the last video. I called it object vignette by text accord, and the duplicate I will name object vignette by corner ID. In create event I changed the info text for the base project. And since we're using corner ID and not UVs in this video, I can delete all the UV stuff here. Everything between sprite equals and shader equals. As well as the 2 handlers used for the UVs, UV center and UV dimensions. We'll call the new shader vignette by corner ID and I'll set it up right here already. And then we need to enable the usage of corner IDs with the function shader enable corner ID. Now in room end event I'll just disable corner IDs again, so this won't ever mess up other test rooms. And in draw event, I just removed the two lines where we had passed the UV arrays to the shader, UV center and UV dimensions. Now we can place the new object in the same room as where we placed the object vignette by text codes. I had named that room vignette by text codes and cone ID. I'll just place the new object below the last one. Now let's copy the shader we created last time. I had named it shader vignette by text codes, and I'll name the duplicate shader vignette by cone ID. Inside the vertex shader we can remove everything we did last time. This part will be completely different. So let's remove the varying vec2 VV frag UV, the two uniforms UV center and UV dimensions, and inside the main function the VV frag UV line as well. But we will need a new varying for now. Varying float corner test. And inside the main function I'll just pass the varying corner test with a constant 0.5 for now. Inside the fragment shader we can remove the varying vec2 VV frag UV as well and add the varying float corner test to receive that from the vertex shader. In the main function, let's just comment out everything and just add one line. glfrag color is a vec4 constructed from corner test, and 1. So all we want to do at the moment is drawing the corner ID information, not the image. And that was set to 0.5 in the vertex shader, so if we run this now, we should just get a gray rectangle. And that's true. So the basic test setup is done. Now back to the question I asked before. How can we read that information on the vertex number from inside the vertex shader? Now as the documentation states, if corner ID is enabled, GMS uses 2 bits to store that information. The lowest bit of the red channel and the lowest bit of the blue channel. So to retrieve those 2 lowest bits, we'd usually use bitwise operations. Unfortunately, it seems GLSL doesn't know any bitwise operations, but then again, I wouldn't understand that anyways, yet. That's something on my to-do list. But we can also retrieve bits by using the mod function. In color red times 255 modulo 2 will retrieve the lowest bit of the red channel, and in color blue times 255 modulo 2 will retrieve the lowest bit of the blue channel. Now here's my try to explain how this works, and I hope I'm not totally wrong here. Color data stores R, G and B with values ranging from 0 to 255 each. So if we mod 255 by 2, the remainder is 1, and if we mod 254 by 2, the remainder is 0. If we mod 253 by 2, the remainder is 1 again, and so on and so forth. Now let's look at this again, but this time with binary numbers. 255 in the binary system is 11111111. The lowest bit is the 1 at the right side. If we mod this by 2, the remainder has to be 1. 254 in a binary system is 11111110. And if we mod this by 2, the remainder has to be 0. 253 in a binary system is 11111101. And of course, if we mod this by 2, the remainder is 1 again. And 252 in a binary system is 11111100. And if we mod this by 2, the remainder has to be 0. And so on and so forth. So we can observe that mod 2 always retrieves the lowest bit. However, I can only explain this by observation and not in a more mathematical way. It also becomes clear that this system can only hold information for 4 vertices. 2 bits can only be 0 and 0, 0 and 1, 1 and 0, and 1 and 1. But 4 vertices is enough to describe a rectangular plane, and that's what a sprite is to the shader. Now we know how to retrieve the corner ID bits, but it's still difficult to understand how this will help us. So it's time for testing. Inside the vertex shader, we now retrieve the lowest bit from the red channel of the vertex color. So comment out corner test equals 0.5 and instead add corner test equals mod of incolor.r times 255 by 2. So we're checking what the corner ID bit in the red channel is for each vertex. Let's run this again. Now one important thing to mention. I did once get wrong results with these tests. If you're doing this lesson alongside watching this video and get different results, try cleaning the target and run again. This should fix the problem. Okay, this is weird. Vertex 0 in the upper left corner is black, so the vertex color is 0, 0, 0. Vertex 1 in the upper right corner is white, so the vertex color is 1, 1, 1. Vertex 2 in the lower right corner is black, and vertex 4 in the lower left corner is white. Weird, but it's something to work with. We now know the corner ID bit of the red channel is 0 for vertex 0, 1 for vertex 1, 0 for vertex 2, and 1 again for vertex 3. Now back in the vertex shader, let's comment out that line and add another one. Corner test is mod incolor.b times 255 by 2. So now we're checking what the corner ID bit in the blue channel is for each vertex. Let's run this again. Now that's different. Now vertices 0 and 1 are black, so the corner ID bit in the blue channel of those vertices is 0. And vertices 2 and 3 are white, so the corner ID bit in the blue channel of those vertices is 1. And that's helpful too. We now know the corner ID bit of the blue channel can be used as y-axis going from 0 to 1. But then how is the corner ID bit of the red channel helpful? How can we get the x-axis from that? Let's have a look at the visualization of what's happening here and how we can use this. This is the image we got from the least significant bit in the red channel. The vertices of the sprite are numbered clockwise from 0 to 3. We can see GameMaker Studio has set the vertex 0's lowest bit in the red channel to 0. In vertex 1, the lowest bit in the red channel was set to 1. In vertex 2, the lowest bit in the red channel was set to 0 again. And in vertex 3, the lowest bit in the red channel was set to 1 again. This is the image we got from the least significant bit in the blue channel. Here we can see GameMaker Studio has set the vertex 0's lowest bit in the blue channel to 0. In vertex 1, the lowest bit in the blue channel was set to 0 as well. And in vertex 2 and 3, the lowest bits in the blue channel were set to 1. So again, this can be used as y-axis of our coordinate system, but we still need our x-axis. But that's pretty simple really. We can get the difference of both bits by subtracting one from another and getting the absolute value. In vertex 0, 0 minus 0 stays 0. In vertex 1, 0 minus 1 is negative 1, and the absolute value is 1. In vertex 2, 1 minus 0 is 1. And in vertex 3, 1 minus 1 is 0. So this is our x-axis. And if we display this as coordinates, we get this. The upper left corner now is 0, 0, the upper right corner is 1, 0, the lower left is 0, 1, and the lower right is 1, 1. So we got our normalized coordinate system. I hope this was understandable. It's difficult to explain, and I realized I only really began to understand this while preparing this video and the graphs. It took me several hours to prepare those sheets, but I hope that was worth it. But anyways, now we can create and test the x-axis in our shader as well. In the vertex shader, comment out the corner test line again and create a new one. Corner test is the absolute value of mod incolor.b times 255 by 2 minus mod incolor.r times 255 by 2. So now we're testing what happens if we subtract the corner ID bit of the red channel from the corner ID bit of the blue channel and retrieve the absolute value of this. We should now see the x-axis. Let's run this test once again. Et voila! Now we got the x-axis of a coordinate system ranging from 0 to 1 as well. This means the x-axis is just the difference of the two lowest bits. Now let's confirm what we just learned. If all this is true, then we can do the same without enabling corner ID. I don't mean using the corner ID function by GMS is bad. What we're going to do now is just for testing. So far we learned the code in our vertex shader is just retrieving the lowest bit of the red and blue channel of each vertex's color. And with the function shader enable corner ID, GameMaker Studio just changes the lowest bit of the red and blue channel of the vertex color. Now if that's true, then we can do the same without that function by setting the color of each vertex manually using drawSprite general instead of drawSprite. So let's test this. In create event, disable the usage of corner IDs. In draw event, I'll first get the sprite's dimensions, the width and the height. And inside the shader block, I'll draw the sprite giving each vertex its own color. For vertex 0, I'll just set red and blue to 0. For vertex 1, I'll set the red channel to 1. Mind that this format is BGR, not RGB. So the first two digits are the blue channel and the last two digits are the red channel. For vertex 2, I'll set the blue channel to 1. And for vertex 3, I'll set both red and blue channels to 1. So this is the same as we had seen in the graph before. And I expect the result on the screen to be the same as in the last run, representing the x-axis. Let's run this. And yes, this is as predicted. Now back in the vertex shader, let's reuse the blue channel and run this again. Now the result is representing the y-axis. I guess this proves and clarifies what corner ID is. As the documentation says, just the lowest bit of the red and blue channels of the vertex color. It was just really hard to understand without help on the forums, thorough testing and some terrible headache. I really hope Yo-Yo Games will add a description usable for hobby programmers, because what's in the documentation now was just useless to me. But before moving on, let's remove the test lines in the draw event and set the simple drawSprite function again. And let's re-enable the usage of corner IDs in the create event. Now there's another thing I need to explain. How does corner ID affect the image? We are stealing one bit from the color channel after all. If you're not using VV color in the fragment shader, nothing happens at all. Because the corner ID is not stored in the sprite, it's stored in the vertex color. If you are using VV color, nothing really changes either though. The lowest bit of a color channel has minimal impact on the color itself. We can easily visualize this. Here you see some randomly colored boxes on the left side. And here on the right side, the same colors with just one bit change in the red channel or blue channel or both. I cannot see a difference here at all. However, I'm not sure if you'll see a difference in the video. I got no idea how this codex is storing colors. If you want to read the forums post that helped me understand all this, check the link section in the description of this video. There's a link to an example by flyingsaucerinvasions and a link to an explanation by Barts. You hopefully have an idea how corner ID works by now. So let's finally start coding the vignette. The object can stay as it is. It's really the same as the object for vignetting with UVs minus the UV part and plus enabling corner IDs. We already did that in the beginning of this video. So let's move on to the vertex shader. Here we can remove or comment out everything related to our tests. So the varying float corner test and corner ID test equals 0.5 and so on. Then we need to add a new varying. A vec2 this time to pass the x and y coordinate of our corner ID based coordinate system. Varying vec2 corner coord. And now we just need to create that coordinate system. First I'll get the red bit and blue bit and store those in a local float. Then I'll get the x-axis, which is just the absolute of corner blue minus corner red, or the other way around if you want, it doesn't matter. And the y-axis, which is just corner blue. We will still need VV text code, by the way, because it's needed to draw the sprite. The corner ID will just be used to draw the vignette. In the fragment shader we can comment out or remove everything related to the earlier tests as well. So varying float corner test and the GLFrag color line. Now let's uncomment the code that was still here from the vignette by text chords shader. We can keep the vec4 base call line. We still need the image's pixel call after all. The calculation of the distance of each fragment to the center needs to change though. The vector we're interested in now is not VV frag UV anymore. It's simply corner chord. That's the fragment's position in our corner ID coordinate system. However, we need to get the distance to the center, so we need to subtract 0.5 from corner chord. However, that's something we could do in the vertex shader already. So let's remove the 0.5 here again and add it to the vertex shader. And the rest of the vertex shader and fragment shader can stay as they are. So as you can see, the shader didn't become easier, actually much more complicated to understand. But we don't need to get UVs anymore. We don't need to pass the UV center and dimensions to the shader anymore. That's all handled by our normalized corner ID coordinate system. Now let's just run this and see. And we can see it works exactly the same way as with using UVs now. I realized this is not easy to understand, and I hope I could still explain corner ID as well as possible. To me, this definitely was the most difficult and time-consuming video as of yet, although I fear the next few won't be easy either. But I also hope you all enjoyed this and learned a lot. So now that we've learned the coordinate systems in this and the last couple of videos, here's a question. If you'd want to create a vignette post-processing shader, which coordinate system would you pick? In position, GLFrag chord, VV text chord, or corner ID? In position, that seems off the table, unless you want to darken or lighten the corners of the room. I have trouble imagining why anyone want to do that though. Then maybe GLFrag chord. That does make sense. It's based on the view after all. And several code examples and tutorials use the GLFrag chord to draw the vignette. A viable option. But I'd need to pass in the view dimensions to calculate the center and the distance to the center. Or maybe texture coordinates? Dealing with UVs can get tricky, and I'd usually want to avoid tricky. Also, I'll need to pass in dimensions as with GLFrag chord. So is corner ID maybe the best answer? Corner ID is great because I got the coordinate system going from 0 to 1 in both directions. Center is always 0.5, calculating the distance is easy, and I don't need to pass in anything. So corner ID it is? Well, I'd probably go with texture coordinates anyways though. If we're creating a post-processing shader, we're definitely going to shade a surface. And a surface's texture coordinates range from 0 to 1 as well. That means handling UVs is easy. We don't need to pass in the dimensions like in GLFrag chord after all, and we don't need to create the coordinate system from the corner IDs, nor do we need to enable corner IDs in the first place. But here's a thought. Does it really need to be a shader? Maybe I'd just be as happy to create a vignette sprite in Photoshop, maybe only a fourth of the size of the view, and draw that stretched and interpolated over everything on the GUI layer. I can even animate that as well without using shader uniforms. I can dynamically change alpha, I can change color, I can change size, all without using a shader. What I'm trying to say is this: don't get overexcited with shaders if there's another way to get what you want. With this tutorial series, I don't want to say everything needs shaders. I'm just trying to show how shaders can be created and try to teach at least one new thing per video. And vignetting was a really great shader to explain VV text code and corner ID. In the next few videos, we'll get into other rather complicated but also very elemental stuff. we're going to create a blur shader. Might sound boring to some, but again, it's a very good way to teach some important concepts, and blur is the foundation several effects build on. So this is something every shader hobby programmer should learn. We'll start with a very simple but horribly inefficient version, and then add performance boosts in follow-up videos up to a point where we can easily run a huge and super smooth full HD blur on a tablet at 60 FPS with enough power left for the game to run smoothly. I'm quite excited about that, and I hope you are as well. Until next time.